According to the 2020 National Electrical Code, which is NFPA 70 type FPLP CMP plenum rated, fire alarm cable is not required to be installed in Conduit when it is installed in a plenum space. A plenum space is defined as a compartment or space that is used for the movement of environmental air. Plenum air is air that is used to cool equipment, such as computers and servers. The concern that the cable may be exposed to damage if it is not installed in Conduit may be a misunderstanding. The NEC specifically allows type FPLP CMP cable to be installed without Conduit in plenum spaces. This allowance exists because type FPLP CMP cable is designed to be fire resistant and to withstand the high temperatures that can occur in a plenum space. When fire alarm cable is installed above a suspended ceiling in a single-story office building, it is generally not exposed to damage from foot traffic or from other activities that could occur in a plenum space. Therefore, it is often not necessary to install the cable and Conduit in that particular situation. Let's delve deeper into the specifics of FPLP CMP cable and its installation requirements. Firstly, it's crucial to understand what constitutes a plenum space. A plenum space is not just any area above a suspended ceiling. It's a designated space used for environmental air movement, often integral to the building's heating, ventilation, and air conditioning or HVAC system. Secondly, FPLP CMP cable is specifically engineered for use in these plenum spaces. The CMP designation signifies that the cable meets rigorous fire safety standards, including low smoke and flame propagation characteristics. This is vital because in the event of a fire, standard cables can release toxic fumes and contribute to the spread of flames through the plenum, potentially endangering occupants. Thirdly, the NEC provides clear guidelines on cable installations in various environments. While Conduit offers physical protection to cables, it's not always mandatory. The NEC recognizes that certain cable types, like FPLP CMP, possess inherent properties that make them suitable for direct installation in plenum spaces without Conduit. Let's consider the factors that influence the decision to use Conduit or not. One important aspect is the potential for physical damage. If the cable run is in an area where it could be subjected to impacts, abrasion, or other forms of mechanical stress, then Conduit may be necessary to protect the cable's integrity. Another factor is the presence of corrosive substances. If the plenum space contains chemicals or other materials that could degrade the cable's insulation or conductors, then Conduit may be required to provide a barrier against these substances. It's also important to consider local building codes and regulations. Some jurisdictions may have more stringent requirements than the NEC, mandating the use of Conduit in certain situations, regardless of the cable type. Now, let's examine the specific requirements for FPLP CMP cable installation in plenum spaces, referencing the NEC. The NEC addresses wiring methods and materials for communications systems in Article 800. Specifically, Section 800.113 outlines the requirements for cables installed in ducts, plenums, and other spaces used for environmental air. This section permits the use of listed plenum cables, such as FPLP CMP, without Conduit, provided they meet certain conditions. The conditions typically include proper support and securing of the cable, as well as adherence to ampacity and dating requirements. Ampacity refers to the current carrying capacity of the cable. It's essential to ensure that the cable is adequately sized to handle the intended electrical load without overheating. Dating is the process of reducing the ampacity of a cable when it's installed in an environment with elevated temperatures or when multiple cables are bundled together. This is done to prevent the cable from exceeding its temperature rating and potentially causing a fire hazard. In addition to the NEC, other relevant standards and guidelines may apply to fire alarm cable installations. For example, in FPA 72, the National Fire Alarm and Signaling Code provides comprehensive requirements for the design, installation, and maintenance of fire alarm systems. This code addresses aspects such as cable routing, termination, and testing. It's crucial to consult both the NEC and NFPA 72 to ensure that the fire alarm system is installed in accordance with all applicable requirements. Let's also touch upon the different types of fire alarm cables available. Besides FPLP CMP, there are other types of fire alarm cables, each with its own specific applications and limitations. FPL, or Firepower Limited, cable is a general-purpose fire alarm cable suitable for use in non-plenum spaces. FPLR, or Firepower Limited Riser, cable is designed for vertical runs and riser shafts. These cables have different fire resistance and smoke propagation characteristics compared to FPLP CMP cable. Therefore, it's essential to select the appropriate cable type for the specific application and environment. When installing fire alarm cables, it's crucial to follow best practices to ensure a safe and reliable installation. Firstly, always to energize the circuit before working on any electrical wiring. Secondly, use appropriate tools and equipment for the job. Thirdly, carefully inspect the cable for any signs of damage before installation. Fourthly, properly support and secure the cable at regular intervals. Fifthly, avoid sharp bends or kinks in the cable, as this can damage the conductors. Sixthly, use approved connectors and terminations to ensure a secure electrical connection. Seventhly, thoroughly test the fire alarm system after installation to verify that it is functioning correctly. Let's consider some common scenarios where conduit may be required for FPLP CMP cable, even in plenum spaces. One scenario is when the cable is exposed to physical damage. For example, if the cable is running along a wall in a high-traffic area where it could be bumped or kicked, then conduit may be necessary to protect it. Another scenario is when the cable is installed in a hazardous location such as a chemical plant or a gas station. In these environments, conduit may be required to prevent the cable from igniting flammable vapors or gases. A further scenario is when the cable is required to be shielded from electromagnetic interference, or EMI. EMI can disrupt the operation of electronic equipment and can even cause false alarms. In these cases, metal conduit can provide a barrier against EMI. It's important to note that the decision to use conduit or not should be based on a thorough assessment of the specific installation environment and the potential hazards involved. In addition to physical protection and EMI shielding, conduit can also provide other benefits. For example, conduit can make it easier to pull cables through walls and ceilings. It can also provide a neat and organized appearance to the wiring installation. Furthermore, conduit can protect the cable from moisture, dust, and other environmental contaminants. However, conduit also has some drawbacks. It can be more expensive than installing cable without conduit. It can also be more time-consuming to install. Therefore, it's important to weigh the pros and cons of using conduit before making a decision. Let's discuss the importance of proper grounding and bonding in fire alarm systems. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are essential for safety, as they help to prevent electrical shock and fire hazards. In fire alarm systems, grounding and bonding are particularly important because they help to ensure the reliable operation of the system. A properly grounded and bonded fire alarm system is less susceptible to noise and interference, which can cause false alarms. It's important to follow the NEC requirements for grounding and bonding when installing fire alarm systems. The NEC specifies the size and type of grounding conductors that are required for different types of equipment. It also specifies the methods for bonding metal parts of the electrical system together. Let's also consider the importance of surge protection in fire alarm systems. Surges are brief spikes in voltage that can damage electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Fire alarm systems are particularly vulnerable to surge damage because they often contain sensitive electronic components. To protect fire alarm systems from surge damage, it's important to install surge protective devices, or SPDs. SPD are designed to divert surge current away from the equipment and into the grounding system. SPD should be installed at the service entrance and at any other locations where surges are likely to occur. The selection of SPD should be based on the specific voltage and current requirements of the fire alarm system. In conclusion, the installation of FPLP CMP cable in plenum spaces without conduit is generally permitted by the NEC, provided that the cable meets certain requirements and is not exposed to physical damage or other hazards. However, it's important to carefully assess the specific installation environment and to consult with qualified electrical professionals to determine the best course of action. Proper grounding, bonding, and surge protection are also essential for ensuring the safety and reliability of fire alarm systems. Remember to always follow all applicable codes and standards when installing electrical wiring. Let's also touch upon the topic of cable management in fire alarm systems. Proper cable management is essential for maintaining a neat and organized installation. It also helps to prevent damage to the cables and to ensure that they are easily accessible for maintenance and repairs. There are several different methods for managing cables, including using cable trays, cable ties, and cable clamps. Cable trays are metal or plastic structures that are used to support and route cables. Cable ties are plastic or nylon straps that are used to bundle cables together. Cable clamps are metal or plastic devices that are used to secure cables to walls, ceilings, or other surfaces. When choosing a cable management method, it's important to consider the size and weight of the cables, the environment in which they will be installed, and the accessibility requirements. It's also important to ensure that the cable management method complies with all applicable codes and standards. Let's delve a little deeper into the specific requirements for supporting and securing cables in plenum spaces. The NEC requires that cables be supported and secured in a manner that prevents them from sagging or drooping. This is to prevent the cables from putting stress on the connectors and terminations, which could lead to electrical problems. The NEC also requires that cables be supported and secured in a manner that prevents them from being damaged by vibration or movement. This is particularly important in plenum spaces, where there may be air handling equipment that can cause vibration. There are several different ways to support and secure cables in plenum spaces. One common method is to use cable hangers. Cable hangers are metal or plastic devices that are attached to the ceiling or the support structure. The cables are then hung from the cable hangers. Another common method is to use cable ties. Cable ties are used to bundle the cables together and then to secure them to a support structure. It's important to use cable ties that are rated for use in plenum spaces. These cable ties are made from materials that are fire resistant and that do not produce harmful smoke or fumes when burned. Let's also discuss the importance of labeling cables in fire alarm systems. Proper labeling is essential for identifying the different cables in the system and for troubleshooting problems. Cables should be labeled at both ends, and the labels should be clear and legible. The labels should include information such as the cable number, the circuit number, and the destination of the cable. There are several different ways to label cables. One common method is to use adhesive labels. Adhesive labels are printed with the information that you want to include in the label and then applied to the cable. Another common method is to use cable markers. Cable markers are small plastic tags that are attached to the cable with a cable tie. The information that you want to include on the label is then written on the cable marker. It's important to use labels and markers that are rated for use in plenum spaces. These labels and markers are made from materials that are fire resistant and that do not produce harmful smoke or fumes when burned. In addition to labeling the cables, it's also important to keep a record of the cable routing and connections. This record can be in the form of a drawing or a spreadsheet. The record should include information such as the cable number, the circuit number, the destination of the cable, and the location of the cable run. This record will be invaluable when troubleshooting problems with the fire alarm system. Finally, let's consider the importance of regular maintenance and inspection of fire alarm systems. Regular maintenance and inspection are essential for ensuring that the system is functioning properly and that it is ready to respond in the event of a fire. The maintenance and inspection should be performed by qualified personnel. The maintenance and inspection should include the following tasks: checking the batteries in the fire alarm control panel, testing the smoke detectors and heat detectors, inspecting the wiring and connections, and verifying the operation of the alarm notification devices. The maintenance and inspection should be performed at least annually, and more frequently if required by local codes or standards. A well-maintained and inspected fire alarm system is a critical component of a building's fire safety plan. By following the guidelines and best practices discussed, you can help to ensure that your fire alarm system is safe, reliable, and effective. Remember that the information provided here is for general guidance only and should not be substituted for professional advice. Always consult with qualified electrical professionals and local authorities to ensure that your fire alarm system complies with all applicable codes and standards. It is vital to stay up to date with all code changes, as the NEC is updated every 3 years. Keep abreast of all local amendments and interpretations.